Hello guys, welcome to today's tutorial. I'll be taking you through a sneak peek of what the final website will look like at the end of this tutorial today. Now that we've already covered the dairy models, we'll be moving on to building the front end using Angular. Before we start, let me give a quick overview of what we'll be covering today. We'll have a home tab, this one here, an about us page, and also a contact us page. I'll also talk about the technologies that I'll be using to build the front end, mainly Angular. So, without further ado, let's take a look at the final website at the end of the tutorial today. The home tab will be the first page that a user lands on when he or she navigates to our website. It will have some little information in it. Then the about us page will be showing a little bio or maybe a short bio about our farm. And then the contact us page will provide a form for feedback. Straight to our home page where we have a little button here that takes us to the cow list page. This will be the list of the cows that we have in our farm. We'll be able to add a new cow. For example, right now we can add a new cow, a cow number 6, a breed of Guernsey. Let's give it a date of birth of today, then assume that it's a male, it's alive, then save it. And you can see we have the cow number 6 in our database. You can also update it. These are the records of the cow. This is just a placeholder image because for now we've not added the functionality of uploading the cow's image. We'll be able to update the cow's data, and also we'll be able to delete the cow. And as you can see, the cow is now gone. And so let's dive into the code. When building a web application, there are typically two main parts, the front end and the back end. The front end is what the user sees and interacts with, and the back end is the behind-the-scenes code that powers the application and handles tasks such as the data storage and retrieval. Django REST framework is a powerful tool for building the back end of a web application, in this case our Django application. It allows you to create APIs that can communicate with other applications such as mobile apps and other websites. And with Django REST framework, you can easily serialize and deserialize data, handle authentication, permissions, and many more. On the other hand, Angular is a popular front-end framework that allows you to build dynamic and interactive user interfaces. With Angular, you can create components, services, and other elements that make up the user interface of your web application beautiful and interactive. When used together, Django REST framework can provide a powerful and a flexible solution for building applications. Django REST framework provides a backend API that Angular can communicate with, while Angular provides the front-end interface that can interact with that API. And so, let me use this analogy. We can think of the backend as a factory that produces the goods and the front-end as the storefront that displays and sells these goods. Django REST framework is like the factory producing the data in a format that can be easily consumed by other applications. And Angular is like the storefront displaying the data to users and allowing them to interact with it. In summary, using Django REST framework and Angular together can provide a powerful and a flexible solution for building web applications. Django REST framework provides a back-end API, while Angular provides the front-end user interface. Together, they can create a seamless user experience that makes it easy to interact with data and build dynamic website. So I'll go ahead and install the Django REST framework. As you can see, this is the official website where there's the documentation. And so, to install the Django REST framework, we'll need to copy this pip install Django REST framework. I've done so, and the installation is already ongoing. And so, as my installation is going ahead, we will need to create a new file called serializers.py in our dairy folder. That is our dairy app. In this file, we shall add the code that is responsible for converting the data or the information from the database to and fro. And now, I know you're wondering why we're converting this data. We're converting the data first of all to JSON format. JSON format is a format that all programming languages understand, and that's the reason why we are doing this, because the backend that we've been doing in all other previous tutorials is written in Python, and the front end that we'll now be starting to write right now is written in JavaScript. And so, to ensure that we do not have issues or we do not run into issues, we have to make this data consumable by all programming languages. When we create APIs with Django REST framework, we often need to serialize our data so that it can be easily transferred over the internet. Serialization is the process of converting data into a format that can be easily transmitted and reconstructed later. And in Django REST framework, we use model serializers to convert data from our Django models into a format that can be serialized and transmitted over the internet. Model serializers are a powerful tool that can automatically handle many of the common serialization tasks, such as converting the dates and times into standardized format. And to use the model serializer, we first create the serializer class that inherits from the model serializer class by the Django REST framework, as shown here. Now our serializer will be called the cow serializer because actually it will be serializing the model cow. We then specify the model that we want to serialize, that is this one, and also the fields that we want to serialize. For now, we want to serialize all fields for the cow model. And it's worth noting that there are 3 fields that have this read-only specification. This ensures that these fields are not manually entered, because if you might remember, in our models the tag number, the parity, and the age are being calculated automatically, so it does not make any sense to allow the user to enter these ones. It's quite important to note that in the previous tutorials I had defined the breed as a single standalone model, but I realized that this would quickly make the code really complex and very difficult to maintain, and so I decided to do away with it and rewrite the cow model. So for now, I'll delete the 2 and paste the new cow model that is rewritten and has the breed. As you can see, now it's not a foreign key. It's now a choice field of the breed choices inside the cow model. So far, we've refactored the cow model's code, and now we'll need to create a view to handle the logic of listing, creation, updation, and deletion. So I'll simply go ahead and pre-populate this file with this code. And if you might remember, when we were creating this daily app, Django went ahead and created this views.py file for us. So it knows this is how Django works. It has the model layer, the view layer, and the template layer. So the model layer was the one that is handling how the data will be structured and all that stuff. The view layer will be handling the logic of updating, deleting, and listing, and all those stuff, and maybe other custom validations. And so this our view code will be leveraging on the Django REST framework model view set. So this is how it works. A model view set has the list function, the create function, the retrieve function, the update function, and the destroy function. And now the list function takes in a query set of all the cows, serializes them, and then returns a response of the serialized query set. So the create function takes in the requested data, serializes it, checks if it's valid. If it's valid, it will save and return a status code of 201. A status of code of 201 means that something has been created successfully. And if the serializer is not valid, it will return an instance of serializer.errors with a status code of 400. A status code of 400 is a bad request, meaning that the request that has been sent either is lacking something, missing something, or has some malicious stuff in it. The retrieve function will retrieve a specific cow, or maybe a single cow, based on an ID or a primary key. Then it will return a response, a serialized response that is. And the update function works in almost a similar way to retrieve, but it has some element of now posting a new data as well. So basically, if the serializer is not valid, it will return a status of 400, meaning that there's a bad request. You see, you might be having a cow with correct records, but the moment that you update it, maybe you update it with some erroneous data, so it will not work. And finally, we have the destroy function. As the name suggests, this function deletes the cow from our database. And so now that we've already created our views, we'll need also to create a urls.py file, so that we use this file to contain all the URLs for our views. Django REST framework provides a very easy way to do this. We only define an instance of a router and then registers the path and the view set. And this will be able to provide all these routes. a view set for the viewing, so we'll be able to view, that is to list, to create, to update, and delete. All these are already handled inside this URLs pattern. And now, with all that done, we'll move to the front end. I went ahead and created a new folder for the front end because it only makes sense that if the backend is written in Python, the front end is written in JavaScript, we don't need to mix up languages, so we'll be confused in just a short while. So I went ahead and installed Angular in this folder. In order to install Angular, you'll need to head over to their official documentation website, where you'll use this syntax npm install the Angular CLI. And after doing that, now we'll start generating the components for our front end. Angular and Django are somewhat the same in how they operate. Remember how we created a new app in Django? All we needed to do was to write the python manage.py, start up, then the name of the app. In our case, it was dairy. So the same principle applies to Angular, but in Angular, we call them components and not apps. Components are the building blocks of Angular applications. They are reusable pieces of code that encapsulate the template, the styles, the behavior of part of a user interface. Components are defined using the combination of TypeScript, HTML, and CSS. They have specific structure that uses a decorator, a class, in the template. The decorator provides the metadata for the component, such as its selector, any dependency it needs. The class contains the logic for the component, such as the methods and properties. The template defines the HTML structure of the component and how it should be rendered. Components can also communicate with other components and services in Angular application through input and output properties, and by using the dependency injection. Overall, components are fundamental part of building Angular applications, as you will see. Now that we've talked of components as specific parts of our application, or rather our website, let's think of our website as this. We need to have a component for the home page, a component for the About Us page, and a component for the Contact Us page, as well as we also need components for things like listing the cows, creating the cows, updating the cows, and all that stuff. And so now that we've talked of the components such as the home component, the About Us page, and the Contact Us page, we'll need to create separate components for this, as this carries separate logic. And so this is the syntax. The ng, which stands for the Angular, G stands for the generate, and C stands for the component. So this instructs Angular to create a component by the name home. If you do that, then Angular will ask you some questions as this, and for this we give it a yes. And so Angular went ahead and created this folder component for us. For now, we'll need to create all those other components too. The one for daily.about us, it did that too. Then we give it another instruction to create for the Contact Us page. Contact us, as well as the navbar, that's the wrong spelling, daily navbar, that's okay. I think we also need a footer, so the last one is the footer. And so with that done, we have 5 folders for all our components. We have the daily About Us, the daily Contact Us, the daily footer, the daily home, and the daily navbar. All these will contain the logic about this specific set of the components. And now we have the 5 folders and additional one, the cow folder, where we will need to create the responsible components for the dairy cow. A dairy cow could be having components such as the dairy cow.list, the dairy cow update, the dairy cow detail, and the dairy cow delete. And now we have all other components too responsible for the dairy cow. So I'll go ahead and explain what a component entails with one example now that all these are components. For example, let's start with the dairy cow.create. But before we do that, let me just close all these other files responsible for the backend and come back to the dairy cow.create. This component has 4 files, the TS files, the HTML, and the CSS. The CSS is responsible for styling the HTML markup, and then this one is responsible for testing. We won't be using it for now. Then this one is responsible for handling the logic, responsible for creating a new cow from the client side, that is from the user interface. These others two operate in the same manner. And so I'll go ahead and pre-populate the data for these components, then explain them. At least for now, I'll only explain maybe 2 or 3 because the logic is the same. It cuts across all other components. This is the end result, but one more thing remaining is to include Tailwind in our project. Heading over to the Tailwind official documentation, we'll need to copy this script tag here and put it inside our head tag as instructed here. So we'll put it in the head tag of our index.html because all those other templates will inherit from this one. And just like that, we have Tailwind already included in our project. And now we'll add also Flowbite for styling too. Head over to the CDN, and we'll also need to include this in our head tag. This one is for styling too. Let's copy it and add it just under the Tailwind. And then there's one more to copy too. This one here for the JavaScript files of Flowbite. Then this one will add under the body tag as instructed here. So just before the end of the body tag here, we put it there. And with all that done, we have everything we need for our styling. So I'll go ahead and explain these components: the dairy about us, the dairy contact us, footer, and the rest. These 5 components, this one, this one, this one, this one, and this one, do not have a lot of logic, and as you may attest to, the dairy about us only displays some dummy text about our farm. Likewise, the contact us page has some mock-up form for contacting our farm. The footer too has some markup to just design how our footer will look like, similar to the home and the navbar. And so, because these 5 components do not have much logic, so I'll go into the cow. This component represents a form for creating a new cow object. The components import several dependencies at the beginning of the file. For example, here, we import the component and the onInit from the Angular/core. These are Angular decorators used to define a component and its lifecycle hooks. And now we import the cow from this folder, the dairy/models here. I had structured this cow class to inform our front-end Angular the type of data that it shall be receiving from the backend. And so this is how I define this class. It has these several fields that corresponds to our cow model in our backend: the ID, the name, the breed, the date of birth, etc. The string corresponds to characters, meaning that a name will be having something like Peter Evans, and also it will have an ID which is a type of number. So our frontend knows that when it receives this data from the backend, this data will be formatted this way. And so we import it here. We also have the cow service and the router imported too. I had manually written this cow service code in the interest of time, so I'll go ahead and explain it. But before I even explain it, think of service in Angular like a personal assistant. Just like how a personal assistant helps you with tasks that you need to get done, a service in Angular provides functionality to other parts of the application. For example, a personal assistant might help you schedule meetings, book travel, or even manage your calendar. Similarly, a service in Angular might help you retrieve data from the database, perform calculations, or communicate with either an external system. The great thing about having a personal assistant is that they can help you with tasks that are common across different parts of your life, and in the same way, a service in Angular can help you perform tasks that are common across multiple components in our application. And in our case, all other components such as the daily cow create, detail, list, update. And so, just like how you can share your personal assistant with other people in your organization, you can also share a service with other components or services in our Angular application. This makes it easy to reuse the functionality across different parts of application and to keep our code organized and maintainable. Overall, a service in Angular is like a personal assistant that helps us with tasks that are common across different parts of our application, making it easier to manage and maintain our code. And now that you have a simple analogy of how a service functions, I'll go ahead and explain this service code. This service is named a cow service because it provides methods for interacting with the API to perform the CRUD, that is the create, read, update, and delete operations on our cow objects. And this service imports several dependencies at the beginning of the file. We have this injectable from the Angular/core. This is an Angular decorator used to make the service injectable into other components or service. So actually this is what makes it reusable in all other components. Then we also have the HTTP client. That's also a service that provides methods for making HTTP requests such as the GET, the POST, and the PUT. All are available in this. This service has a private API URL property, and it's private because we only want that this URL is accessible within this service. It makes sense because if we make this public, we might end up with errors maybe in future development, or we can have some bugs in our application that might be very difficult to debug. And so this service has 4 methods: the get cows, the create cow, the update cow, and the delete cow. This method retrieves either a single cow or a specific cow by its ID, or all cows if the ID is not provided, and it returns an observable that emits a response from the HTTP GET request made using the HTTP client. And so let me break it up a little bit. The ID question mark is just a shorthand syntax of checking if the ID was available or not, and this method returns an observable that emits a response from the HTTP request made using the HTTP client. The create cow method creates a new cow by sending a HTTP post request to the API with the provided data. It returns also an observable that emits a response from the HTTP post request made using the HTTP client. And so it's worth noting that this data is of any type because we could have dates, we could have name of a cow, all that stuff. And you see, these are different data types. You have the number, you have the string, and all that stuff. And now we have this update cow method that updates an existing cow object by sending an HTTP put request to the API with the provided ID and data. It also returns an observable. I do believe that this ID should be in number format, because that makes it quite appropriate. And in our last method for deleting a cow, this actually sends an HTTP delete request to our API, and it also returns an observable. And so it's worth noting that all these methods return an observable, which means that by calling the component where this service will be injected, we can subscribe the results of the API call and receives the response asynchronously. And now that I've already explained all that the cow service does, we'll now go back to the dairy component. And in this component, the new cow is the new instance of the cow that will be used to store the data entered in the form. Cows is an array of the cow objects that will be displayed on the page. And then the breed is an array of string values representing the different cow breeds that we shall have in our farm. The name touched, male selected, and the show tooltip are all Boolean flags that we will use to style our template, or rather our form. The name touched is a Boolean flag that indicates whether the cow name field has been interacted by the user or not. The male selected is a Boolean flag that indicates whether the cow gender field has been set to male. And now, the show tooltip is a Boolean flag that indicates whether the tooltip should be displayed. And now in the constructor, we specify the two dependencies, the cow service and the router. The cow service allowing us to create a new cow, and the router letting us navigate back to the list page after the cow has been created successfully. The ng on init is a method in the Angular lifecycle hook that is called when the component is initialized, and in this case is empty, but for some reason I just place it here not to run into issues and errors. The onSubmit method is called when the user submits the form. It calls the createCow method of the cow service to make a HTTP post request to the server with the data from the form, and once the request is successful, the newly created object is added to the cows array. The object to mean the newly created cow is added to the cows array, and the page is redirected to dairy/cows, that is the route for listing the cows. And so, let me explain how this works. We will use the createCow method from the cow service, and remember this cow service we had injected in this component using the constructor here. And so, this method createCow returns an observable that's actually a representative of our HTTP request from this new cow, and we subscribe it, or rather save it into an instance. Let's call it a variable of a created cow, and then we push this created cow into the cows array so as to update our cows list. Upon a successful save, we now redirect the user to dairy/cows. So now that we're done with the logic behind the form, let's head over to the HTML, the actual form styling. And in this, we have several directives. Starting with anything in between the parentheses, this is how Angular understands it. This is an event. So for this case, this means that this is a submit event, and if this form is submitted, it will trigger this function in our component here, the onSubmit, and all the stuff inside that function will be executed. It's worth noting that we have some directives such as the ngIf, the ngModel, and the ngFor. So I'll start by explaining what a directive is. A directive is a special kind of instruction that you can add to an HTML markup to tell Angular to do something specific. For example, ngIf is a directive in Angular that allows you to conditionally render HTML elements based on certain expression. For example, here we use the ngIf to check if the name is touched and there's no cow name, then we tell the user that the name is optional. And the ngFor allows us to loop over a collection of data. In this case, we are looping over the breeds, and the breeds is provided in our components here. Remember, we have defined the property breeds here. And we also have here another click event. I had said that anything inside parentheses is an event. And so, in the interest of time, I won't go through all these other models. I'll only go through one, dairy cow detail, which has a class component, the dairy cow detail component, which has an additional activated route injected here. This one allows this component to actually extract the ID and then perform the get cows. Remember, this get cows was accepting the ID, and if it was not having any ID, it was defaulting to retrieving all the cows. Then it does the same stuff as the createCow method, and then it also has an additional onDelete method, which actually confirms if you actually want to delete this cow. And now, with all that done, it's now time to go and check if everything worked out. We need to fire up the server by writing ngserve, and boom, now we have our server up and running. So we'll go ahead and access it at port 4200, and wow, this is our dairy homepage. We have our homepage, about us page, and the contact us page. The about us page, our short bio of our farm. Then the contact us page, a fictitious form, or maybe a mock form of our form that we'll be using for people to contact us. Then in the home page, we have some little dummy text here too that most of dairy websites do have in their website. And then this button for us to view our cow list. For now, we only have a single cow in our database, so I'll go ahead and add a new cow. And so, watch me do this. If I hover over this field, we get this tooltip. The name is optional. This is achieved by the fact that we have defined a boolean field and defaulted it to false, the name touched, that if any event that the mouse hovers over the field, then it will turn this name touched to true. So it works this way. If the name touched is equal to true and we do not have any cow name, then it will render this field. The name is optional. So that's basically how this works. But the moment that you start entering any cow's data, then it will disappear. So let's give this cow a breed of Jersey, and then let's assume that it was born on 26th of February. And also here, it makes sense that if we have the female gender selected, then we have all those other pregnancy status unlocked. But if it's a male, then only a single one, because a male can never be pregnant or those others. So it makes a logical sense. So assuming that this is a male, a female that is, then it's alive. Availability status is also defaulted to alive, because it makes only logical sense that the moment that you're adding a new cow record, that cow has only to be alive and not either dead or sold. Those ones will change over time. So now let's give this as a not pregnant. If we save it, it will redirect us straight to the list of the cows. And if you hover around, you'll see some gray background. Click on any of them, it will take us to the detail page of that specific cow. So this is how the detail page looks like. For now, it only has a placeholder image, but in future we'll implement the images for the cows and they will be displaying here. The details are designed this way, and we can update the details. And remember, now we have the fulfills and stuff like the availability status of sold and dead. They are now available. And also, if we try deleting a cow, it will bring us a prompt, or it will shout at us, are you sure you want to delete this cow? If you give it OK, it will go ahead and delete the cow and redirect you back to the cows list page. That's it for this tutorial. Thank you for staying up to this end. This tutorial has been quite a long one, but there's no harm, because I'm pretty sure you've learned a lot of new stuff. And so please share, like, subscribe, and give me feedback too if you feel that there's somewhere that you need me to incorporate something, or maybe there is something that you didn't understand better. Just write in the comment section, and I'll see you in the next tutorial. Bye bye.